Okay, let's talk about the elephant in the room. Why is it called normal saline when it's far from normal? Well, it's actually historical. Um, Back in the day when they were producing chemicals with different concentrations, normal was considered to be 0.9% sodium chloride dissolved in water. So 9 grams of sodium, 9 grams of chloride dissolved in water, right? Now, that was called normality. It's got nothing to do with normal being the normal concentration of sodium chloride in your blood, because that's vastly different. So let's have a look at the comparison. Inside a bag of normal saline, you're looking at 154 millimoles of sodium and 154 millimoles of chloride. Now, that is very, very different to what's going on in the blood. Together, they represent, in that bag of saline, they represent a osmolality of about 303. So let's say 300, just to be friends, which makes the fluid roughly isotonic. And what that means is that when it goes into your bloodstream, it doesn't cause your red blood cells to take on water, swell and burst, nor does it cause your red blood cells to dehydrate and lose water into the plasma, right? The concentration is isotonic. If it was hypertonic, then that would shrink your red blood cells. If it was hypotonic, then your red blood cells would take on water, and in fact your blood would take on water and you'd increase your volume eventually. But that's another discussion. The osmolality of your blood sits at around about 280 to 290. The osmolality of a bag of normal saline, 0.9% sodium chloride, sits at about 300. So it's ever so slightly hypertonic, not perfectly isotonic. You'd want that to be about 290 to be isotonic. Okay, now let's talk about the sodium. The sodium in your blood sits at 135 to 145. In a bag of saline, that's 154. So there's more sodium in the bag than what there is in your blood, if your blood was normal. So it does give sodium to you. In other words, it increases your sodium. Makes sense, doesn't it? If you're putting something that's got 154 into blood that sits on average around 140, then of course you're going to get an ever so slight increase. But where its big problem comes into play with large volume resuscitation using normal saline is the chloride concentration. Now, the chloride in your blood sits at about 98 to around the 108 mark. So let's say 100 to be friends. That's your normal chloride. But the chloride in a bag of normal saline is 154. It's the same as sodium. So at 154, there is way more chloride than what there is in your blood. And for that reason, as you start pouring sodium chloride into a person's body, normal saline into a person's body, that extra chloride starts dissociating. And it loves to dissociate from the sodium and find some other positively charged ion, and that's usually hydrogen in the blood. So now you're starting to form hydrogen chloride molecules, which is acidic, hydrochloric acid. And large volumes of resuscitation with normal saline, therefore, will make you become acidic. That's the short. I could have done that in a 4-second video. Normal saline gives you acidosis, hyperchloremic acidosis, but you would have wanted more. So I gave you the more, and here's the punchline. Don't give too much normal saline. This is why we move to something a bit more balanced, a balanced crystalloid solution. There's something along the lines of plasmonite or even just Hartmann's, if we're going to aggressively fluid resuscitate someone. There it is. Up to 2 litres, probably not that much of an issue. Anything over 2 litres, you'd want to go with something balanced. Normal saline, far from normal.